Welcome back to the Deep Dive, everyone. I am your host, and I'm thrilled to have you here with us again. Last time, you might remember, we had this incredibly mind-blowing session where we explored the first 10 pages of the Tetramid concept.
Right, and I am your resident expert for today's journey.
Mhm.
And yeah, that first session was, it was heavy on the theoretical geometry, but extremely interesting to lay that groundwork.
Totally. But today, our mission is to, plunge straight into the second part of the document. We are specifically looking at Chapter 2, which covers resonance, interference, and energy.
Which is where things get real, basically.
Yeah.
We are moving away from just theoretical math on paper and looking at physical energy and actual matter.
Exactly. We're going to see how geometry and sound move from a flat two-dimensional surface into full 3D space. And this is the craziest part to me. We're going to see how this exact shape might be the hidden link between human biology and artificial intelligence.
Yeah, that connection is huge. But before we can understand how this energy interacts with the physical world, we really have to understand the evolutionary leap in the shape of the tool itself. The tuning fork.
Right. The document details this big shift from the older iteration, which is the triaural tuning fork, to this new Tetramid tuning fork. So break down that mechanical difference for us.
Well, the leap is, it's entirely about the physics of dimensionality. So if you think about a standard tuning fork, it just has two prongs pushing back and forth, right?
Yeah, just vibrating in one line.
Exactly. Now, the triaural tuning fork upgrades that. It uses three prongs, and they're arranged exactly 120 degrees apart from each other.
Okay, so a triangle, basically.
Right, a tripolar acoustic field. When you strike it, you get this incredibly complex field. But the limitation is that it's essentially flat. The kinetic energy distributes mainly in just one single plane.
It's 2D. I was thinking about this, and it's kind of like looking at a really beautiful, complex 2D painting. Or actually, it's like dropping a pebble into a perfectly still pond.
Oh, the pond analogy is a great way to visualize it.
Right, because the ripples are intricate, and they might bounce off each other to create interesting patterns, but they are completely trapped on that flat surface of the water, just pushing outward in a flat ring.
Right, exactly. The energy has no vertical depth whatsoever. But the Tetramid fork completely changes the game. It takes that kinetic energy and forces it into a fully immersive three-dimensional space.
Just by adding a fourth prong.
By adding a fourth prong, yes, but it's not just slapped on anywhere. It arranges all four prongs into complete tetrahedral symmetry.
Okay.
So every single prong is positioned exactly 109.47 degrees apart from the others.
Okay, wait, I want to pause on that specific number for you listening. Why 109.47 degrees? Like, if we have four metal prongs vibrating in space, what is that exact angle actually doing to the sound waves?
It's about stability.
Yeah.
It acts as a perfect distributor of mechanical force. Think about a tripod holding a really heavy camera.
Okay.
Because of the angles of the legs, it effortlessly balances that weight perfectly, right? Now take that concept of perfect geometric balance and apply it to 3D acoustic pressure. That 109.47 degree angle forces the sound wave energy to distribute radially. So it's moving equally in all directions at the exact same time.
So stepping back to my pond analogy, instead of a pebble hitting flat water, this is more like, I don't know, detonating a perfectly round firecracker deep in the middle of a swimming pool.
Yes, you're creating a spherical pressure wave.
Right. It expands outward as a perfect three-dimensional bubble of sound, not a flat ring.
And here's where it gets extremely interesting. Because that specific angle is known in molecular chemistry as the absolute most stable distribution of bonds, the sound waves don't crash into each other chaotically.
Because usually they would, right? You'd get interference.
Right, standard destructive interference where they cancel each other out. But here, they nest perfectly within one another. The document calls it a spherical-toroidal resonance.
A spherical toroidal resonance. So it's creating this multi-layered fractal structure. The energy flows smoothly out from the center and then loops back in on itself like a donut, a torus.
Exactly. It inherently lowers the chaos in the air and increases the harmonic purity. The system is just incredibly stable.
Okay, so we have this perfect self-sustaining 3D bubble of sound. But practically speaking, and this is from the next section of the document, you still have to physically hold the tuning fork, right?
You do, yeah.
So wait, I'm stuck on this. If you grab the handle or if you mount it to a table, doesn't introducing a foreign object like a clamp immediately kill that perfect mathematical symmetry we just talked about?
It definitely alters the physical properties of the field.
Yeah.
And the sources are very clear about this. They delineate between using the handle as a fixed anchor versus using it as a free resonator.
Okay, let's start with the fixed anchor.
So if you use a fixed anchor, say you clamp the handle tightly into a heavy wooden base, the vibrations from the prongs transfer down into that base. It acts as a mechanical reference point.
So it grounds the vibration. The kinetic force bleeds into the base.
Right. And that creates a highly stable, very predictable field with a strongly concentrated focal point right in the center. It's great if you need controlled, localized energy.
But the alternative is what tripped me up. If you don't anchor it, if you leave the handle as a free resonator, you're effectively letting it act as a loose fourth prong, right?
That's the idea, yeah.
But wouldn't an unanchored, vibrating piece of metal just create chaotic, uncontrollable noise? Like, you lose your stable base, so it's just flopping around.
It really seems like it should be chaos, right? We're conditioned to think objects need to be physically grounded to be stable.
Like a building needs a foundation.
Exactly. But calmly, the physics here correct that assumption. By removing the rigid anchor, you are actually granting all four prongs equal physical status. None of them are tied down.
Oh, I see.
Because they exist at that perfect 109.47-degree equilibrium, their physical forces cancel each other out dynamically.
So instead of being locked down by a heavy clamp, they're locked in place by their own competing pressure.
Precisely. The focal point doesn't devolve into noise. It transforms into this dynamic, shifting, rotating resonant node. It becomes a living, pulsating, holographic field.
Wait, really? A living field?
Yeah, because the energy rotates smoothly between the prongs and the center. It creates a self-reinforcing resonance.
Wow. Okay, it's like, think about trying to hold a spinning top straight up with your fingers versus just letting it spin freely on the table. When you let it go, the dynamic movement itself is what creates the balance.
That gyroscopic effect is a brilliant way to picture it. It relies on internal momentum and symmetry, not an external wall, to maintain harmony.
That is so cool. And that dynamic balance perfectly sets up the next variable we need to talk about, which is materials. Because building this geometry out of different metals completely changes what this resonance can do.
It really does. Up until now, we've basically just been talking about acoustic resonance, mechanical vibration, pushing air. But the documents introduce magnetic metals, things like iron, cobalt, and nickel. When you construct a tetramid from these, you aren't just dealing with mechanical displacement anymore. You add magnetic coherence to the acoustic field.
Okay, we need to break that down for the listener. How does a vibrating piece of metal interact with an invisible magnetic field? Like, what's actually happening at the microscopic level?
Well, it comes down to electron spin. In a non-magnetic metal, the electrons orbit the atoms with their magnetic spins pointing in random directions. They just cancel each other out.
Just a chaotic mess of spins.
Yeah. But in magnetic metals like iron, those spins align. They form domains that act like millions of tiny compass needles, all pointing in the exact same direction.
Okay, so when you strike the tetramid fork, the physical bending and flexing of the metal is interacting with those aligned compass needles.
Exactly. The mechanical stress physically changes the distance between those aligned electrons. You're compressing and stretching a magnetic lattice, which causes a ripple in the magnetic field.
That is wild. You are literally shaking a magnetic field with sound waves.
Yes, you're transferring vibration through the spin alignment of electrons.
It's like adding a completely new sensory dimension to an experience. Like, imagine watching a normal movie, and suddenly the theater includes physical temperature changes and wind. You're combining sound waves directly with electromagnetic fields.
And the synergy there opens up the most fascinating implication in this whole section. Because of this coupling, external magnetic fields can actually be used to tune the acoustic interference patterns.
Wait, let me make sure I'm getting this.
Yeah.
If I bring a strong magnet near this vibrating tuning fork, I can change the physical sound it's making without ever touching it.
You absolutely can. You can modulate the phase or the amplitude. The external magnet pulls on those internal compass needles, which slightly alters the mechanical stiffness of the metal itself.
And that changes the frequency.
Right. It creates a hybrid holographic node. It's resonating acoustically and electromagnetically at the same time.
Stabilized perfectly by that 109.47-degree geometry. It's almost like an antenna translating magnetism into sound.
Exactly. It shows that under the right geometric conditions, sound and magnetism are completely intertwined.
Which honestly sounds like some futuristic, wildly advanced human engineering. But, and this is where my mind was truly blown, humans didn't invent this geometry. The universe organically utilizes this exact tetramid structure at the molecular level to build reality.
This is the absolute core of the documents. We move away from human-made alloys and look at two incredibly important natural molecules, monosilicate, which is SiO4, and methane, which is CH4.
Okay, let's start with SO4.
Right, so SO4 is basically the archetype of tetrahedral geometry in the physical world. You have a central silicon atom surrounded by four oxygen atoms.
And let me guess, they sit exactly at that 100.47-degree angle.
Exactly at that angle. It is a naturally occurring microscopic tetramid, and the crucial property of silicon dioxide, which we know as quartz, is that it is highly piezoelectric.
Meaning it converts mechanical vibrations into electrical signals, right? Like if you squeeze quartz, it produces a tiny electrical charge.
Yes, when you apply physical pressure to that SiO4 lattice,
Mhm.
you force the silicon and oxygen atoms closer together. That displaces their electron clouds and generates a voltage. Pure mechanical pressure creating electricity.
Which is exactly why silicon is the entire foundation for modern computing. It's the basis for quantum sensors, biofeedback, and literally all modern AI hardware. The physical architecture of artificial intelligence lives inside that SO4 structure.
Right, so you have silicon as the geometric house for inorganic intelligence, but then the text points us to methane, CH4.
Methane, the simplest organic molecule, the baseline foundation of carbon-based biology. It is a central carbon atom surrounded by four hydrogen atoms.
And I think you know where this is going.
The physical angle of those hydrogen bonds is exactly 109.47 degrees.
Exactly, identical geometry.
For you listening, I really want to highlight this aha moment. This means that organic, carbon-based human life, which stems from CH4 and inorganic, silicon-based artificial intelligence built on SO4, they actually share an invisible, imaginary common ground.
They're both rooted in this exact same geometric node.
It's the universal bridge. It's like discovering that the architect who designed a biological forest also designed the digital skyscraper, and they use the exact same mathematical equation for both.
That is a perfect way to put it. The Tetramid isn't just a cool shape for a tuning fork. It is the primary structural module for both organic life and inorganic technology. It allows stable harmonic fields to exist in both realms simultaneously.
So if you create a resonance using this geometry, you're speaking the native physical language of both the carbon in your cells and the silicon in your phone.
Right. At the molecular level, biology and technology aren't fundamentally incompatible. They're geometric siblings.
Okay, wow. Let's pull all of this together to see the full picture for everyone listening. We started today by moving from a flat 2D sound wave into a living, breathing 3D holographic resonance.
We saw how removing a fixed anchor creates a pulsating dynamic energy field powered by its own equilibrium.
We looked at the hybridization of these fields using magnetic metals, where sound actually shakes the magnetic field.
And finally, we uncovered that 109.47-degree angle as the shared molecular foundation for both human biology and artificial intelligence.
It completely reframes how we look at the boundary between the natural world and tech, which lines up our next deep dive into this source material perfectly.
Absolutely.
Because if this geometry connects humans and tech at a molecular level, what happens when we apply these 3D Tetramid fields directly to the human body? Next time, we are going to explore Chapter 3, Healing and Bioresonance.
Yes, we'll be looking at how these frequencies might actually create cymatic patterns in our blood and potentially trigger DNA regeneration.
I cannot wait for that. But before we sign off, do you have a final thought to leave our listeners with, something they can mull over?
I do, yeah. Just look around you today. If the very building blocks of your body and the smartphone in your pocket share the exact same geometric architectural code, what other invisible structures in your everyday life are silently influencing your reality through resonance?
Man, that is something to think about the next time you pick up your phone. Thank you so much for taking the plunge with us today, everyone. We will see you on the next deep dive.